Hi, I'm Andrei, and I'm going to talk about what's that head over there? About someone's head over there. This is a slightly unusual talk for me because it's not technical, but it's I find it very interesting from a cultural perspective. I don't plan to sell you on joining Facebook, although we do have job openings. I don't want I'm not trying even to convince you to join Facebook if you don't want to. But I think there's a number of practices that have made Facebook undeniably very successful as a large, it's kind of a big data company, and I wanted to share with you some of these, such that you can take them with you and use them for growing the appropriate culture and way of doing things that have been very successful to us. I'm not saying that's the only way, by the way. It could be like any number of ways. I gotta say that I'm kind of intimidated by the large audience here. I was expecting like there's gonna be like 30 people ragtag, or like, oh, what the hell is he talking about? Like Unix people with beards and stuff like that. But with you guys, I'm seeing like a lot of people rattling their chains, like it's zombies here, like phantoms. Like, do you like the rattling of the chains? It's kind of it's the signature of OSCON 2014. So 5 years ago, almost, it was like 4 and 9 months ago, I was applying for jobs. I was just having finished my PhD. I did the right things in the wrong order. I started my PhD at like the tender age of like 33. And then I finished my PhD, and like, what job am I looking for? Because I've been doing a lot of industrial work, and then I've been doing a lot of research work. I have no idea what would be a good job for me that would allow me to kind of, delve into all of the above. So it was very, I was at sort of a very big dilemma of sorts back then. And I called a friend of mine who was with me in the graduate program at the University of Washington. I said, hey, Greg, I heard you work for Facebook and, for Google, and, Google sounds like a good thing for me. I was like, oh, I'm not working at Google anymore. I'm working at Facebook. What's wrong with you? That was like 2009, right? So even then, Facebook still didn't have the reputation of a serious company. It's like, isn't Facebook kind of a bunch of like PHP scripts, and that's pretty much it? And what's going on there? And he said, no, we're really serious about stuff, and So and I said, I'm finishing I finished my degree in machine learning, and he said, oh, that's music to my ears. We need machine learning. Like, how do you mean machine learning when all you're doing is kind of script kiddies kind of stuff? And this is how it started. It was a wild ride, that's for sure, in which a lot of things have happened, both to me personally and to the company as a whole. And a part of this company's story I'm trying to bring with me today. By the way, so I'm not sure if that's even visible. My title reads research scientist, which is really kind of an engineer. I mean, not kind of, it's an engineer. You got a kind of engineering work. And it sounds nice on a business card, which I never ordered. So I kind of missed out on that one. There are three things I wanted to talk about. Number one is like the way, the incremental way we're building our software. A few things about drinking the Kool-Aid, and a very interesting story about taking risk and conversely not taking risk. All of which I think are kind of relevant. I need to update the numbers every time I kind of talk about these things. Facebook has had an immense growth, and at every stage of the growth, whenever we announce some numbers, the people will say, oh, it's going to go only down from here, and every time it's going to go up and up and up. The more interesting thing is that we had explosive growth on mobile. And mobile is very important to Facebook for many reasons. One is, mobile use through the world is increasing, but also mobile use is huge in developing countries, which are very, we want to help those people communicate. And there's a lot of countries in which mobile use is much more accessible and better developed than traditional internet access. Oh, I'm so sorry. Oh yeah, so when you talk about these things, you're like, yeah, that's obvious. Who can guess? Are you at Facebook? Okay. Monthly active users and daily active users, thank you very much. And apologies for my use of abbreviation. So every month, there's kind of precise definitions for these. Every month, there's this many users being active on either of these platforms on Facebook. And daily active users would be, day after day, there's going to be this many people logging on Facebook. So this is nice because the daily active usage is trailing very closely monthly active usage, and we've seen that the gap has not been increasing; it's been decreasing. There are some numbers here that I don't know exactly how to pronounce. The total number of posts is I think it's commensurate with the depth of some certain countries that I won't mention. There's a bunch of photos out there, again, like a very large number. And like literally as I'm speaking right now, more thousands and thousands of photos are being added to Facebook. Literally like every second that's going on right now, there's more photos. And if you do the math, by the end of this talk, you let me know how many photos there are going to be out there. More. So it's these numbers are staggering. And one simple question would be, how do you handle all that stuff, and how do you make it work smoothly? To do anything at Facebook, there's a lot of moving pieces. It's a very large software, and there's so many things going on at any given moment, and it's all distributed. This photo shows one of our data center, and you gotta kind of appreciate the scale of this thing. Like those matchboxes there, like white, are trucks. Like if one of those hit you, you'd be dead, right? And they're big. It's a truck, right? A truckload of whatever, right? That's a truck, and that's a tiny little box right there. And you got to appreciate how big the data center is. Now, if you go inside, you got to kind of, if it were green, it were the matrix. So it looks kind of very nice for what it does. These are our data centers in which, there's you guys are logging on there, and that machine, you're there, and stuff like that, right? So very interesting. So let's see. Well, one interesting thing about Facebook is that it's a very grassroots-driven kind of company. There's strategic vision, and that's largely shared from the management, but other than like the kind of very high-level strategy, a lot of stuff is decided by the engineers. So there's kind of big strategic decisions, let's work on X. And then there's a lot of work on them, on doing the tactical work necessary. And we're testing and getting feedback all the time, both internally and externally. So, one of these things doesn't look like the others, and PHP has received a bunch of criticism for, someone's taking a photo right now. It's like, oh, I saw him talking about PHP. What's going on? All right, exposed. So PHP has been historically Facebook has, it's been said that Facebook has succeeded in spite of PHP, not because of PHP, etc. It's clear that in the early days, PHP has been the obvious choice for using that kind of software. It was there, it was available, it was very easy to use, install, mess with, and it's been a very productive tool. Over the years, there's been a lot of infrastructure built in PHP for Facebook, and then we got at a point where we had too much code to ignore, so it was impossible to migrate to any other language, even if we wanted. However, I gotta say that the disciplined use of PHP that has been going on at Facebook has compensated with tooling, which I'm gonna talk about some tooling here, has compensated for many of its shortcomings. Moreover, at some point we figured that large modular development needs typing, things like knowing what modules are, what types are, and how they interface. And we have developed a hack language, which you should run and go to the other session that's by Paul Tarjan and Sarah Goleman, like right now, literally this time, right now. So I'm kind of bummed that you're not seeing that as well. Hopefully you're all gonna see it on video, right? So with PHP and Hack, we have developed a very large infrastructure. And there are a few nice things about PHP that other frameworks didn't quite get. So one thing is that it's nice, it has a nice workflow. Just refresh the browser and the script is, save the script, reload the browser, it's there, right? So there's no compilation, there's no linking, and there's no all of that other stuff. And it has no state across requests, which is very nice. A lot of frameworks actually try to keep state between requests, but with PHP, it's like, at the end of the request, all of your sins are forgiven, right? If there's memory leaks, if there's issues, if you kind of forgot to close a file, database, whatever, at the end of the request, it's all cleaned up really nicely. And that has been a huge win for Facebook, it turns out. Has no concurrency, with which comes, it's a blessing and a curse. And the nice thing about not having concurrency is that we go with multiprocessing, multiple processes that are isolated, and so it's a different model of parallelism and distribution than multi-threading. All right, now, you should know that Facebook is very democratic and all opportunity when it comes to programming languages. A lot of our infrastructure is built in C++, though I think there's a bit of C code as well. It's mostly a lot of C++. There's D, with which I've been busy with for the last 6 months, and we're experimenting with at Facebook with good success. There's a bunch of Java. The whole Hive Hadoop infrastructure relies on Java. There's some use of Erlang. There's OCaml. There's even Haskell, which we've open sourced the Haskell library last month. So whatever tool works, you're going to use it, and you're not going to be faulted for it. And this is, I think, a great plus of the company. It's a good thing to have. One other nice thing that I think it's a good proxy for the care of a company to its employees is like what kind of machine they give you. So you kind of join Facebook and you get this freaking crazy machine, which is like 32-way parallelism and 3 terabytes of flash, 144 gigs of RAM, and it can almost compile C++. Right? It's a super machine, right? That was a joke, so those who laugh know why. So it's a very good machine. You can actually install a mini Facebook on it. It's not going to support like a lot of users, but it's going to be essentially you can build and run the entire Facebook on this one machine, which is your own development machine. So you go and you kind of can test your private version of Facebook with your own features and whatever you're adding to it. And this has been actually a great boon for our engineers. There is not one line of code at Facebook that's supposed to not have been reviewed by another engineer, at least another one. So we have Fabricator, which is an open source tool. Who's using Fabricator? All right, a few, but there should be more. It's an awesome tool. It's just fantastic, and it's integrated very well with our internal site in such a way that it allows people to look at diffs and make reviews of the code and commenting on code, lines and sets of lines in code, and they explain, there's discussion going on, and sometimes it can get pretty heated, like whenever you do something like while I'm moving this star from one space before to one space after. That's a disaster, like everybody's going to jump on that, right? And at the end of the day, there's going to be acceptance, and we have these nice GIFs and graphs and kind of animated GIFs with no, don't do that, and your lack of cursor is disturbing and that kind of stuff. Kind of juvenile at first sight, but it's a nice part of the day to have these humorous ways to interact with your fellow developers. And at the end of the day, there's acceptance. The diff has been accepted, and you get to pull it in. Unlike GitHub, where it's the other person who pulls the request, right? So on Fabricator, you get approved, and then you yourself pull the code in. All right, so there's this funny remark that Facebook is never down, and it's not never, but whenever it's down, it counts. It's on the first page in the press, and there's a reason for that. It fails so rarely because if it failed like every week, there would be no headlines about it, right? It would be a common happenstance. But Facebook really, kind of in a very good sense, never fails. Why do you think that's the case? I'm actually taking questions. Why do you think it's the case that Facebook is always on? All right, here's the thing. Whenever you press, so let's say you're on Facebook and you do something and you get kind of a weird error page, right? And what do? You press refresh the page, right? What do you think is going to happen then? Your request is going to go through the load balancer to a completely different server that has a completely different state and whatnot, and it's going to hit the proper version of the software. It is possible that once in a lifetime you're going to see some code that has not been released yet, and I'll explain exactly why later. But essentially, there's these 1% rollouts of features that may fail, but the moment they fail, the people refresh the page and they go to a completely different server. The probability of you hitting the same server in kind of 2 successive steps is extremely, extremely low. It's almost 0, right? So that's why Facebook doesn't fail. It's because, simply put, you're running a different software every time you refresh the page, which is kind of interesting. The hashing algorithm has been subject to quite a bit of work. So, well, let's see how we can do that. And think of this. I mean, this is not a website. Facebook is not a website. It's a common misconception that, Facebook has a website located at facebook.com. It's not a website because every person in the world has their own homepage. It's a different page for everybody. It's an application. So, you go to Facebook. What's the home site? The homepage of Facebook is like, please log in, right, and get login and password. Right, so you log in, and then it's your own thing. It's not the website, right? It's all dynamic. It's generated dynamically every time for every user. So to make that work, there's a lot of moving pieces, and to make those moving pieces not break the site and not die of thermal death, we have a very organized and automated process to it. So twice a day, we release the front end. Every single day of the week, twice we release the front end. So there's a new code, there's a new front end shipped every day, twice. It used to be once, but we're like, I can't wait for that crap. I just implemented my feature. I want to see like in the afternoon, like right now. Let's make it work. And then there's the heart surgery cycle, which is every 2 weeks. Heart surgery is we replace the compiler, the interpreter of PHP that's running the site. It's called HHVM. Who's heard of HHVM before this? All right, a few. Those who didn't, HHVM, it's awesome. It's our JIT compiler for PHP, which is very fast and which powers the entire site. Not site, sorry, the entire Facebook application. And it's a large C++ program. I'm going to use it as a running example for this talk. Now, every 1 week of development, we're going to cut the release branch of the compiler of HHVM. And then we're going to stabilize it internally. So first we'll be deploying it internally. So our employees use a lot of dogfooding. They're seeing the development version of the website of Facebook, and they're going to just use it for a week. And then we're going to launch the release branch after the next week, so every 2 weeks. So now there's a lot of dogfooding that we use. Actually, one nice thing about Facebook is you get to hang out on Facebook all day long and nobody's saying anything. You get to waste time on Facebook all you want because you're there. So, right? It's your right. And actually, there's just a bunch of stuff that's going internally on Facebook. We have our own groups, we have our own discussions, we have everything. A lot of stuff is happening as a Facebook app or as a Facebook feature. And as the diffs I just talked about, the way we review code and stuff is integrated. You get to fix your diff, and you get to internalize feedback, meaning you release the internal Facebook. It's the freshest version of the compiler, and you get to actually you can select there in the lower bottom corner. Don't look for it because it's not going to be there unless you're a Facebook employee. You can run the public version of the site, you can run the beta, you can learn the latest production intent, and so on. So there's plenty of dogfooding going on. And let's talk about the heart surgery part, which would be the HHVM product. So as I said, every 2 weeks on Sunday night, there's a cut. There's a fork done in the version control software, and on Sunday night, this is going to be the code frozen for the next 2 weeks. Is there a question? Okay. And the release candidate, the RC, release candidate branch, is going to be run for a week internally. And then when we release it, we're going to not release it like all at once. It's going to be released incrementally and slowly. Why do you think so? Question? Why do you think we don't push the whole thing at once? In case it breaks, how do we detect it breaks? There's two, the users, okay. There's two things. Number one, if it breaks, you're gonna see a wild change in metrics. So we follow CPU, we follow network throughput, we follow a lot of stuff. And the moment you release a wrong version, you kind of start deploying it to 1%, 2%, 5%, 10% of your users. If a metric is going to start going like this or like that, and you weren't expecting it, it's most of the time a problem there, right? So you can, whoa, let's pull that back, right? So let's put the pace back in the tub, right? So now, if it goes smoothly, most of the time you're going to see like a nice smooth transition from one to another. But I have an example that's going to show you something going wrong, just for kicks. All right, so this is an A/B test, and what do you think happened? So we have a CPU instructions relative, and it was going pretty nicely until it went down by a lot, like 70 relative. Why do you think that happened? Well, it just so happened that at that point, there's a bug in the renderer that rendered only half the page. So rendered half of the Facebook page and kind of stopped there. The bottom, the bottom was not rendered at all. And it was a huge win in CPU time, which was good, right? But obviously, it was not desirable to have that kind of win. So immediately you see that and you're like, oh, something's wrong there, because we weren't expecting that win. You usually expect like 1%, 2%, 5% wins, and we pull that back. Jenkins is our nice automated way of reminding us that when something goes wrong, because you can't have like human beings looking at those patterns all the time and deciding things. So we have like automated systems that actually email you whenever something's changing by more than one fixed percentage, and whenever something's odd, unusual, weird, Jenkins is going to inform. It's going to send email to support and stuff like that. Similarly, like we track things like throughput on the site. I can't really show you the real numbers because they're closely kept secret. I have no idea why. But essentially, we're tracking everything that can be tracked. That's a good proxy for the workings of Facebook. And here we have things like CPU idle. We want to keep CPU idle pretty low, so we kind of use our systems well. We want to keep, of course, the request per second high, and so on and so forth. And here I think you're seeing a successful release in which a lot of metrics change favorably. Remember, it was an upgrade of the compiler. And we also have, at the data center level, there's a bunch of metrics that kind of follow a longer time span and aggregate over a larger number of servers. So, for example, if a data center would be down, you'd see it immediately. It would be like a dead point there. And we have like incredible reliability. You can actually you can turn a whole data center off and have it. The rest of it, Facebook still works. It's just going to work slower. It's still going to work. All right. So one interesting thing is that we are always tuning, and there's something interesting about tuning, because we're tuning, for example, the compiler we're tuning for performance, right? So we consider that the performance is a big thing for us. Why do you think the speed of Facebook would be important? I'm asking you. Why would you think speed of the site is a good thing? People won't use it otherwise. Do you know the day Friendster died, do you know how long was the average page load? 45 seconds. So you do something and press a key or whatever, do some stupid mistake, and you're waiting for 45 seconds for the next thing to happen, right? So that would be an extreme. Clearly you don't want to use that. But it turns out there's published research, both by Google and Facebook, that time to interaction is actually a very good proxy for people's inclination to stay on the site, explore the site. Because, otherwise, if the site is slow, you see a number of links and things you could click on and you could try and could write and could do, right? But what the hell, am I going to do that? I'm going to click on that crap so that I wait for a minute there, right? So the page loading speed is actually a very good proxy of overall quality and enjoyment of the site. And that's a good thing. But don't forget, at some point it may become, obsolete. Something else may be a better metric. So it's important that you keep an eye on the ball. What's the end goal you're optimizing for, and optimize for that thing, right? And it turns out that right now for HHVM, page loads is a good proxy. But tomorrow it will become something different. Like for example, there's a nice anecdote in the automotive industry, which goes like this. There are these cars that run like on a square, rectangular track, and there's contests and stuff, and people would optimize the cars for that kind of workload. And one guy put some wings on the car. And everyone said, that guy is stupid because there's only 4 corners and most of the speed is like on the rectilinear portions, right? But the guy kind of destroyed everybody. Like he was the fastest by far. What happened there? It turns out that the margin, everybody was speeding on the rectilinear portions, but it was the curves that would make people lose time, right? So it was that little thing, that little tiny fraction that made the whole difference. And of course, next year everybody did it, and the field got leveled again. And with HHVM, we've been very good at practicing this philosophy of compounding the 1%. There's a story of the best decade in British cyclism. So there's this gentleman who was like, you got to restore the British cyclism in the world, professional cycler. So he was the manager of the team, and what he did, he said, I'm going to improve everything by 1%. And there's a nice story. Like if you just Google for improve everything by 1%, you're going to find that story. And the way it goes is he improved everything. The diet, the pillows, the creams the athletes used, the bikes, the material they wore, everything, the helmet, you name it, right? The mustache, you got to trim that mustache, it's too big, right? That kind of stuff. I'm making stuff up, right? I don't know about that. But anyhow, it was the littlest things that compounded together led to like the best decade of British cyclism in like forever, right? And at HHVM, we've done exactly the same. There's 1% and 1% and 1%, and they add to like 8x. And it's amazing, right? So this has been kind of a very wild story that's been happening. I'll talk more about that in the taking risks part, but let me talk a bit about drinking the Kool-Aid. And one unusual thing about Facebook, is that we don't hire for teams. So you get, hire at Facebook, and which team do I join? Well, we don't know. You're a Facebook engineer now, and you're supposed to go through the 6-week boot camp, which is a kind of unique thing designed by Andrew Bosworth, Facebook executive, and you go through this process in which you learn a lot about the way the company works in terms of like technicalities. You watch videos. There's classes we have. There's courses. You fix bugs, and the first week actually there's people fix bugs that go to 1.2 billion people, 1.3, right? So literally in the first week of work, you get your work impact more than 1.25 billion people, right? So it's pretty amazing. After boot camp, you have a very good idea of what the teams are and what's going on, you know, where to go. And then there's enough chemistry built with a particular team that you can say, you know, I want to join those guys, right? So that's very rare. By contrast, every large company that I know of is going to be like, well, this is your team because you're a specialist in this particular thing. At Facebook, there are a few specialists, but not too many. Most people are good generalists with a few specialization areas. Like myself, I'm kind of a machine learning specialist, but that doesn't prevent me from working on straight software engineering issues that have nothing to do with machine learning. I also used to work on machine learning as well, which is a very nice thing for my many passions, right? There's a lot of internal mobility, which is also unusual. How many of you work in a company where you get to like change your team whenever you want? Awesome. Those of you who didn't, you should be able to, because it's a good thing. At Facebook, after I think 18 months of employment, you say, you know what, I'm going to do a hackathon. There's an encouragement to do so. A hackathon is for 1 month you work with any other team you want, kind of thing. So work with any other team for a month, and at the end of that month you get to decide, well, I'm going to stay with this new team or I'm going to go back to my old team, and it's all fair. And I know people who never took a hackathon. For example, myself, I never took a hackathon. I had the opportunity to change teams as things went, but there's people who don't want to, there's people who want to, and you know, it's up to you really. And then after that, that goes every year, so you get to do that. And I think that's fantastic because it has some nice effects. It's like the free food that has like unexpected effects and stuff like that. For example, it's hard to have crappy teams if you have this mobility. Why is that? Yeah, people would vote with their feet. They would just leave that crappy team and go to a good team. And the good teams would get all the good people, and the crappy teams have no people, right? So it has unexpected effects, and the thing is, wherever you turn at Facebook, there's going to be a good team working on something, right? And the focus is on impact. We look at the best people of the best people. We're looking at finding the diamond in the rough, because there's this way of making things work, which is you get the best people and you let them lose, pretty much, right? One thing about process. How many of you use a formal process at work? All right, I'm kind of bummed a bit because there's too many hands. At Facebook, there's very little formal process, but there's a caveat that comes with that. What's good process? It's achieving extraordinary results with okay people, right? But the thing is, at Facebook, you already have like very good people, so you don't need that much process. So it's a kind of a give and take kind of thing, right? All right, so there's a few projects at Facebook, such as Hack itself, that started as simply like 1 or 2 or 3 crazy engineers deciding to do something about something. And one of them is a look back with the most played song of all times, right? A look back 2013, like last January. Infrastructure, there's a bunch of grassroots movement there, and there's just a bunch of interesting stories about going around our PHP infrastructure. Let me tell you something that I'm going to skip through a few of the slides here because I want to kind of skip to the interesting anecdotes rather than showing you kind of numbers and boring things. One nice thing is that, you know, keeping the eyes on the ball has to do a lot with having the ball there at all time visible. This is a photo taken literally by my team's area. You have it there, you have the goals, you know where you are. Every single day, you come in the morning, it shows you where you are and where you want to be. There's a lot of communication internally going on. Clearly, the leaders are listeners. You can get like flame wars between like the executives and the employees, and it's kind of fun to follow. And let me tell you, let me finish with a nice story here. The storage of HHVM, which has been like sort of an ongoing legend happening. So here's the thing. We figured PHP is too slow for Facebook. We're wasting too much heat, right? We started 3 projects. One was PHP Server, which was an incremental improvement over PHP. The second was I forgot the name, but it was some sort of dyno, forgot the name. But there's another sort of incremental take on improving PHP speed. And the third was compiled to C++ statically. And the nice thing is that these three teams worked on the same problem concurrently in three very different ways. And one project was very low risk, and the other was like, what the hell are we talking about? Right? Very high risk. Which one do you think succeeded? The incredibly high risk, the static C++ compared to C++. So the way it worked is kind of interesting. So you take the PHP, the Facebook, right? The whole PHP code base, you compile it into a huge C++ executable, which was like 2 gigabytes. We had problems with like hitting like limits, hard limits there in the linker and stuff, right? It was like 30,000 global variables kind of thing. And there's a linear search in the compiler, which was like, whoa, this is very slow. And the GCC folks were like, nobody has like 30,000 globals in their program. And we said, well, we have because we generate them, right? And that was kind of a thing. So anyhow, so that project was, everybody working on it knew they have a 1/3 chance to fail. And that's incredible because failure was not punished. And if you don't punish failure, you encourage people to take more risks. And as it turned out, that was successful. And there are many stories like that. And so the static compiler went, so they improved at it. And it was clear that at some point we're going to kind of hit some hard limits there. And we got worried. And so we started this crazy project, the three guys literally, Drew, Keith, and Jason. They started like this crazy project. Oh, we can't statically compile to C++. That's so stupid. We got to generate code dynamically, JIT. So we started a JIT project, which when it started, like look at the bottom here. It was 5 times slower than 100% would be the reference, the static compiler. And we started with the dynamic compiler. We're like 5 times slower. And imagine you're there, you have the prototype, and it's 5 times slower. And you're like, I'm going to continue doing that. Right? And it's pretty incredible. And these guys have been working at about 60% it plateaued. And you got it, at that point, shit froze. I mean, it was really bad. And people were really worried. Everybody's like, what the hell are we doing here? So the next portion of the curve, which was that steep increase from 60 to 100%, was an assault in which I participated. And it was like people moved to a different room. It was a skunk course, like Lockheed Martin, right? So it was, we moved to a different room and sat down and we're like, you know what, let's get organized about this. And the way we worked was, well, let's put everything that we can work on stickers. You see the negative results area there? Everything that's negative, you put it there so nobody else works on it. Positive results you put up there, and you never work for more than 2 days on anything. So the 3 days would be a hard limit. So work for 1 or 2 or maximum 3 days on something, and if it doesn't work, put in the negative results. And we worked like that for 2 months. And boom. And then again it went asymptotic. And believe it, it fractally repeated itself again, the whole story, because 2 other crazy guys came and said, we got to have a new internal representation, SSA form. It's a complete redesign of the compiler. And they started again, the green line. It started again worse than the baseline. And then they crossed the baseline. And the whole cycle repeated itself again. And who knows what the future is going to hold, right? So it's kind of crazy. So I wanted just to share these anecdotes with you that I think are interesting. There's these 3 things. How do you keep a site that has so many moving pieces working smoothly? It's all about automate everything you can automate. Make sure you have the appropriate tools for doing so. Make sure you work with your coworkers on like the real thing that needs to be you need to focus on. Second, there's a bunch of cultural stuff that I find interesting. It applies well for Facebook. It may port to other organizations as well. I highly recommend it. Things like I don't understand why companies don't give larger monitors to their engineers. But literally, it's like there's a relationship between the productivity of people and the monitor they have. And quite literally, there's a function. Okay, and you go to this company, it's like 15-inch monitors. Really, I left out the door because it was kind of a machine learning company. So I was interviewing with them, and I see this dusty, literally dusty like 486, right? Those who don't laugh, it's a very old computer, right? Because you're too young to kind of give one. There's this crummy old computer with a 15-inch monitor in like modern days, and I'm like, what the hell? Why don't you care about your people, right? And last but not least, the whole risk story, which is, not taking any risk is actually worse than taking big risks. So, thanks very much. Thank you.